left off with sig figs and calculations, and the example that I had given you as we walked out the door was 2 times 5.000. Well, that yields 10.000, except we're limited by the smallest number of sig figs we've got, which is 1. So the answer is 10. Doesn't look like any difference. So let me give you an example that better illustrates the maddening effect of this. 3 times 5.000. What's the mathematical answer? 15. You all know that. But you only have one sig fig to play with. Meaning, what's the answer? 20. What? 3 times 5 is not 20. It's not. Your raw answer is 15. Your final corrected sig figged answer is 20. Good reason to have as many sig figs as possible when taking measurements. In terms of rules for rounding, how many of you remember all your rules from rounding effortlessly? From watching the video, from taking the quiz? People seem to do pretty well with that. And I don't usually see the same mistake in physics that I see in chemistry, which is people wanting to leave off placeholder zeros. The one rule that I will talk about a little bit is the rounding on 5s. And I think your book actually gives the more complicated version of rounding on 5s, where you look at the number after the 5, and if it's even or odd, that determines which way you go. We're operating under the KISS principle, keep it simple, stupid. So for us, 5s are going to go up. When you get to a college physics class, they may use the more complicated rule, which reflects on the digit after the 5 and it being even or odd. The idea is that you've only got 4 numbers that are rounding down. You've got 5 digits that are rounding up. You have a weight towards the high end. And doing that even-odd thing is supposed to balance that a little bit so that it all averages out over the long term, and you don't skew your data upwards. But we're going to go ahead and, like I said, keep it simple. Everything, 0 through 4 rounds down, 5 through 9 rounds up. So hence why 15 becomes 20. Questions? Kind of caps and summarizes. When you are making measurements, you are the one who is responsible for your significant figures. This comes into play mostly on labs. And I already mentioned the example of the force meters that we use, the spring scales, and that different spring scales have different levels of precision. Therefore, and there's a lab, like I said, we do usually right before Christmas break is always my goal. When we do that lab, if you use 2 different instruments, then your calculations across the board will have different numbers of sig figs, and it's your job to track it. And yes, I am enough of a jerk to actually look at which spring scale you used and grade you on your sig figs based on the instrument you used. Like I said, I'm not much of a jerk. So you're in charge of making sure that your level of precision matches the instrument that you're using. If you need any help remembering your sig fig rules, check out your book, check out any of the tutorials I have linked for chemistry. Physics is math-based. In order to represent data in physics, graphs are enormously helpful. Tables are helpful too, especially for visual learners. Graphs are very helpful. I'd much rather have a graph than a table. Though, you often have to have a table to support your graph. You are going to get very good at representing if you already aren't. And many of you probably already are. But one of my goals is to make you even better at it, to push you a little bit on that, and to really increase your skill in not only representing your data in tables and graphs, but in reading and interpreting tables and graphs for data. You've all taken the ACT at least once. Anybody planning to take it again? Okay. So when you take the ACT, I know as recently as a few years ago, and you can tell me if this has changed, the science portion was pretty much all reading graphs and tables. So I feel very strongly that really hammering that in chemistry and physics helps you on your ACT score, and I would like to do that. So that's the goal. One of them. Here's the cool thing. Okay, now I have admitted flat out I am a math geek. I get high on math, a lot in physics. I've had a few students who have also gotten addicted. I had a young lady many years ago, and she didn't take physics. She took calc, she didn't take physics, and halfway through the year she was incredibly sad because all her friends were in physics, and she had discovered the joy of getting high on math, and she said, but when I get a really big problem, and I get it, and she was like jumping up and fist pumping. She was, because yes, there are actual chemical, neurobiological things that can happen in your brain when you're doing math. Parents, talk to your kids about math. If you don't, someone else will. And it's going to be me. So here's the cool, mind-blowing, amazing part. And I am somebody who came more from the math world than the physics world. I struggled in physics. I didn't take it in high school because I was a jerk, and I took it for the first time in college and I barely survived, and the story all made sense, but I couldn't apply the math to it. I could do the math, I could do calculus. I couldn't apply the math to the physics. Being good at math is not the same as being able to apply the math to the physics. You don't have to be in calculus, you don't have to be in advanced math to do well here. I've had people who were in everything from probability, advanced math, and calculus, because this is not just math. This is applying it. Has anybody here seen the movie about Helen Keller, the miracle worker? Okay, big idea, too long, didn't read. Little girl who loses sight and hearing at like 13 months of age, can't speak, runs like a wild child because they don't know what the heck to do with her. Annie Sullivan shows up and finally makes the connection to her that words mean things, because she doesn't get that. She has no idea that these things that Annie is like hitting her hand with, spelling words into her, mean things. And the minute she does, it's like the whole world opens up to her and light shines down and angels sing and, rainbows dance out of her ears. I had a moment like that with physics, and I'm hoping you do too. The actual equations that we are going to use represent the relationship of things in the physical world. That sounds really simple. But the moment that is actually like profoundly true and echoing around in the center of your brain is the first time you get high on math. No, it's not. But no, seriously, it's cool. These relationships are actually shown mathematically. And so it's amazing. Okay, maybe I make too much of it, but I get excited about it. When we are representing these things in the physical world mathematically, we use pretty standard sets of variables to represent them. So v is always speed or velocity. We'll talk more about the difference between those two. Delta is change or difference. Sigma is sum. And t is time. So you will get good at reading sentences. Can you read that bottom sentence? Read it quietly, that equation. Read it quietly to yourself. Delta y equals 3.2 delta t cubed. Yeah. And you'll start to read those fluently. You will become fluent. Evaluating expressions. You have done dimensional analysis, but you may not have called it that. Factor label, which you learned in chemistry, is dimensional analysis. And what you're looking at is seeing if the units cancel. That's all it is. You're examining the units that are present in an equation to see if the equation is a possible reasonable solution. As we get into much crazier algebra, and we're rearranging and substituting, and we've got equations that to get down to a simple solve, you're looking at 2 pages worth of work. It's fun. I can't wait. I have whole notebooks. When you get there, it's really easy to make a dumb algebra mistake, because I've made them all. And dimensional analysis can save your life, because it's a fast way, when you have your rearrangement, to very quickly determine if you completely screwed up the algebra. That's handy. That's a nice tool to have. Did I make a dumb mistake? Boop, 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 boop. Oh, yes, I did. Okay. So let's do a very quick example of a dimensional analysis. Okay, this is a really basic expression that you may have used in physical science. Read it. V equals delta x over delta t. V equals delta x over delta t. V is velocity in this case, and we would usually specify that this is average velocity. Average. We'll talk more about average and instantaneous later. So what units is velocity expressed in? Yes, ma'am? Meters per second typically. So this is meters per second. What units is distance going to be expressed in? I mean, there are a bunch to pick from, but the one that we typically use is meters. Time is in seconds. Is it true that meters per second equals meters per second? Last time I checked. Okay. What that means is that this equation, basically it means you remembered it correctly. Yeah, the units match, it's fine. We're saying that meters per second equals meters per second. Okay, well what if you're struggling, you're grasping, you're trying to remember this thing, you're in the middle of a test and you go, okay, let's see, wait, what is that, what is that, what is that? Whoops, no. V average equals delta x delta t. Well, then we have meters per second equals meters times seconds. Is that true? No. So that's a fast example. These are easy three-part algebra. One of the common things that I see is if you need to solve for delta t, this is where people get all tripped up. If you need to solve for delta t, people always want to, on the first go, do this. Oh, well, that's easy. Delta t equals delta x VA. Let's check that dimensionally. Seconds equals meters times meters per second. So now we have to do some multiplication to figure out what we're really looking at here. I'm going to shrink this. So seconds equals then meters times meters over seconds. So seconds equals meters squared per second. Is that true? No. It's the most common mistake people make when solving three-part algebra. And of course, like I said, I've been doing algebra a long time. I love math. I still screw these up, so I tend to go the long way around the barn. I know that that's not correct. I will actually do this and then solve like that. So I multiply both sides by delta t to rationalize the fraction. Then I can divide both sides by VA to solve for delta t. So that would be seconds equals meters divided by meters per second. Again, that's not true, but have we simplified this? Have we canceled out all the units we can? No, we haven't. So seconds equals, remember that when you're dividing by a fraction, you invert and multiply. Meters times seconds over meters. Seconds equals meters, seconds over meters. Seconds cancel, seconds equal, or meters cancel, seconds equal seconds. Cool. It's a nice little life-saving tool. Now that said, you can have an equation in which the units check out, but there's some other issue. You can also have an equation and a rearrangement in which the units check out, but it's not applicable to the situation at hand because there's some factor you're neglecting or you've forgotten or you've introduced or you've assumed. But if everything else is correct and the units check out, you're at a pretty good starting point. There is actually a practice sheet that I'm going to put up on Classroom, that thing where I put stuff, on dimensional analysis. And it's sort of bigger, badder dimensional analysis. And I want you to practice with it because it's really simple when we're just doing three-parters. It gets a little hairier when we're doing the larger stuff. And I've got half the key done. I'll finish the other half of the key and post that. In the time remaining, you will have time to work on the practice sheet, work on your labs, ask questions, and I'll assign some homework problems from the end of the chapter.